Solutions to graphing linear inequalities. There are 3 steps that should be used when working these kinds of problems. First, you need to get the equation into the slope-intercept form, or y is equal to mx plus b. Secondly, you need to determine whether to use a solid or a dashed line when graphing. Less than or equal to or greater than equal to will be a solid line. All else will be dashed lines. Next, you need to determine whether to shade either above or below the line, and it's best to use a test point. For this equation, you need to add 4x to both sides. This will eliminate the x term on the left side of the inequality. This results in 2 times y is greater than or equal to. But since you want to get y by itself, you have to do the opposite of multiplying by 2. You need to divide by 2. But you'll need to divide all terms by 2. This gives you y is greater than or equal to 3 plus 2x, but it's not really in the y is equal to mx plus b format. So swap the position of the last 2 terms, which gives you y is greater than or equal to 2x plus 3. Next, you'll need to find the y-intercept, which in this case is 3. So go over to your graph at y is equal to 3 and place a dot there. Next, you'll need to find the slope, which is defined as the rise over the run. Looking at the coefficient, or the number in front of x, you'll see it's a 2. This slope needs to be expressed in a fraction format, so let's put 2 over 1. Going back to the y-intercept that you've just plotted on the graph, you need to rise 2 and run 1 and place a dot. Repeat this process until you get 3 or 4 dots to be used to draw your line. Next, you'll need to determine whether this line is solid or dashed. Since you have a greater than or equal to inequality, it's going to be a solid line. So let's connect the dots. Now you'll need to determine whether to shade above or below the line. But let's use a test point, the origin, which means you'll need to substitute in a 0 for both x and y, which gives you this, which simplifies to 0 is greater than or equal to 3. Well, that's a false statement, which means that the test point should not be shaded. So you need to shade on the other side of the line. Notice that the shading stops at the edge of the graph, but in actuality, it should extend out to infinity in the direction of the red arrows.